Okay guys, so I'm only going to do one video on programming and I'm going to make it about Grasshopper. When you work with Grasshopper, you'll oftentimes build components that become slow and sluggish because there's too many inputs to work from. For example, to make a band, you need a, well I've done the band tutorial for you how to make a band. Where is that? There we go, plain band. And you will find that because there's many different things that Grasshopper has to do, that it can be a tad sluggish once it starts getting really big, once these definitions start getting really big, and you then want to jump to programming. So I'm going to walk you through using Visual Studio to do that. So I've already built the component. It's over here. I'm going to walk you through the process of building it. Let's close out Grasshopper. Okay, so in Visual Studio, I'm going to open another instance of Visual Studio. This is just the Community Edition. It's free, anyone can have it. Okay. You need to install the Grasshopper plugin for Visual Studio, which will load up what you need. Now the Grasshopper plugin is not that page. Anyway, just search for Visual Studio plugins. Go to the marketplace, search Grasshopper, and you want the one either for Visual Studio for Rhino 5 or for Rhino 6, depending on which version you're going to be compiling for. Download that, install it, and then when you fire up Visual Studio, just go to Create New Project. And you will see I'm working in Visual C. You can also work in Visual Basic if that's your choice. Come down to Rhinoceros and grab the add-on for version 6. Give it a name, my test, whatever it is you want to do, and click on OK. Once you click on OK, it's going to open. Oh, let me just do it. I have so many test folders already. When you do, you'll see it'll have populated a lot of information for you. I'm going to walk you through my code. I don't work with these default templates. They're mucky and they've got a lot of descriptions in there, which for you I think is important because it tells you how to do everything. All the little green things are little annotations that tell you what each of these things is busy doing. Okay. I'm going to close out this version of Visual Studio. I'm going to go back to mine. Now, this is not to teach you programming. I can't teach you programming. You're going to have to learn C# yourself, or stick with Visual Basic, which is a little easier. All right. I pull out a blank. I edit a blank template, which I save on my desktop, which takes all that long nonsense and all the annotations and it dumps it into a really small thing for me. All of that nonsense on the other page is contained in these lines. Alright, it's a lot of screen space for nothing. So when I do this, I get rid of all the annotations, I bring everything back down, and I bring it to the minimum size that I'm working with, because once you start getting big Grasshopper definitions, you're going to be scrolling through tens, hundreds, maybe even thousands of lines of code. So let's work through this. Up at the top, what are we using? I was going to use lists, so I had that in there, but I can remove it for now. You can probably leave this on default, okay, with whatever it comes up. All that this is saying, it's using system libraries, it's using the Rhino geometry library, and it's using the Grasshopper kernel. And where those are is inside here. Alright. When you use the template, it automatically adds these in here. If you don't use a template, you have to run around looking for these references by adding them in yourself manually. Pain in the ass. Easier to just use the plugin to start you up. Alright, so on the first line, we're saying that we have a Grasshopper component that we're building. I've given it a name. If you hover your mouse over the word base over there, you'll see that it gives you a description of what everything that's required. What is the name of it? What is the nickname for it? The short name that will show up on it. A string description, and then what category you want to put stuff. So I made a category for myself in Grasshopper called Extra. Let's fire it up and show you. And in the extra section I have a couple of things that I've built, my little braid builders and all this kind of stuff, okay? So if you put that in there, it's going to create a new category for you, and all your stuff is going to be together in one place in Grasshopper rather than just randomly spaced around. This leave on default, it'll be as it came out. This leave, well, I changed these. It returns a null over here, which means you get no icon. I'm going to show you what that looks like. It just means what picture do you want to use as an icon up the top here. Or if you're using your display and you're saying draw icons, what icon do you want to use on the component? Alright, so you don't necessarily have to have any. As you can see over here, I don't have an icon. You don't have to have an icon, or you can have an icon. I just put this little alert one on the tutorial that we're doing. Okay. So back into here, you can either import your own bitmap image into here. You can go to in there and you can go add an existing item, and you can find a bitmap image somewhere and you can add it in there and then create a reference to it. I just pull icons from the system icons, or just leave it as is while you're playing around. This is populated for you automatically. It's a GUID that Grasshopper uses to track all its components, and that Rhino uses to track all its components. And then that's all the overhead out of the way, from a whole page of nonsense down to those 4 lines. Now you can start actually working. This will come pre-populated with an example or without an example, depending on what you ticked when you started the builder. This whole section here is what are the inputs on the left hand side of the Grasshopper builder. Let me clean all this nonsense out and put our band down. It's what are the inputs on this side. Okay, so let's have a look at that. You can see I'm registering input parameters. This is populated for you automatically. It may or may not have a name. They normally use some cryptic name in there. I just change the name so that I know what it is. It's my inputs. And you can add inputs by starting with inputs, hit dot to bring up the specific type of input you want. So you can specify that I only want a circle attached to this, or I only want a color, I only want a curve. In this case, I'm keeping it very, very simple, and we're just adding numbers to the left hand side. Okay, I want a inside finger size, I want a thickness, and I want a width of the band that we're going to be building. So I've got a number parameter, number parameter, number parameter. This is my inner diameter, my thickness, my width. And if you hold your mouse over the command, you can see what pops up is you've got a name, a nickname, a description, and how the parameter will be accessed. It's going to be accessed as an item. Alright. If you were going to attach a list of numbers to this, for example, maybe you were building something with a bunch of points and you needed a whole bunch of points as a list, you'd change that to list or tree, as it were. In this case, very, very simple. I'm creating an item and I'm giving it a default value, which means if you pull that thing out with nothing in it, the default finger size is going to be 16.8 millimeter, or if you're working in inches, 16.8 inches. Depends on your Rhino setup. And so the same thing is repeated down here for the thickness, and the same thing repeated down here for the width, with some default values put into them. All right. So you're now done setting up your inputs. You now need to register your outputs. Okay. Again, they come up with some strange names. I just rename it to outputs. Outputs, I want to add a breadth parameter. In other words, I'm going to be creating a piece of geometry that consists of multiple surfaces. I can represent it as each surface as a list if I was wanting to edit them, but I want to output the whole thing as one breadth, as one entire Rhino object. Okay, and I'm going to be calling that a band, and it's going to be output as an item, because there's not more than one item in there. Had you put in over here how many finger sizes and what the step of finger sizes were, you could presumably make 20 bands at a 0.5 millimeter bigger each than each other, and then you'd have to output this as a list so you can access each band. Alright, as I said, keeping it dead simple for now. Alright, and then this is the actual where all the work gets done. This little loop over here is what Grasshopper is running. I try to keep, just my programming style, I try to keep my working code outside of that Alright, and just set up inside here what I need to set up inside here. Okay, you have to define your, because we're going to be getting data from Grasshopper, we need to define the variables for that. Again, like I said, I'm not going to teach you programming. We need a double, because a finger size is not an integer number. It isn't 1 millimeter, 2 millimeter, 3 millimeter. It's a double. It's 1.1, 1.2, 1.3, 1.35. So it's a double value that we need from there. I'm going to just set it. I'm setting it to 0. We wouldn't need to set it to anything actually. So I'm just setting up the variables that I'm going to be working with. Okay, and then my access is fetch a number. Okay, and then it fetches the data from the first variable. Remember that computers speak from the number 0. So this is variable 0, variable 1, and variable 2. So from the first variable, I'm fetching the data and I'm putting it into finger size, and I'm returning. Same thing for thickness, the same thing for width. Alright, so I'm saying fetch and put into there. Okay, so that's those couple of lines there. I'm putting some basic error correction, because you're going to get an error if you're working with zeros. I could have said if finger size equals 0 or equals smaller than 0. I just put it over here because what's the likelihood you're going to drag it down that small? We're jewelers, we're going to work with things that small. Anyhow, this little if statement down here is just an example to show how to add an error to your component, right? So if the finger size is smaller than 0.1, or if the thickness is 0.1, or the width is smaller than 0.1, spit an error. One of your sliders is too small, and return. Alright? I'm going to set the data to do it, which is our little instance solver. I'm going to set the data to the output. There is only one. Right? Remember, it starts from 0, so its number in the outputs is 0. And I'm calling the little routine I wrote, which is make band. Alright, now let's have a look at make band and then get back to here. So I've said that I have my own routine. It's going to return a brep, and its name is make band, and what it's expecting as input is a double of the finger size, a double of the thickness, and double of the width. Now this finger size variable is not that, they look the same, and probably it will be smarter not to name them the same thing. When you come back into the code, you can start getting confused, so you can go in there and just rename the FS. Same thing with thickness, and the width. And you'll see that renaming them in here, it knows they're only part of this, so these are reduced down to just what the inputs were over there. Okay, so the first thing we're doing is up here we're calling this command using this finger size value, which we got from our Grasshopper, this thickness value which we got from Grasshopper, and the width value we got from Grasshopper. We passed them to here and we called it. So make band was passed with whatever value was in finger size, thickness, and in width. And here we start the actual Rhino work. We're creating a new circle called finger rail, call it whatever you like. It's going to be a new circle. It's on the plane world ZX, because we're jewelers, we work, let's close that down, we work in ZX when we make bands, in this world plane here. And it's expecting a radius. Alright, you can see over there it's looking for a double number, which is a radius, not a diameter. So it's the finger size divided by 2, and boom, we now have a circle. It's not in Rhino, you cannot see it in Rhino, but it's been defined, it exists. Now I'm going to create a profile to sweep with, which is going to be a rectangle. And when you do this, you can see that it's looking for the plane you're going to be drawing on, which is not going to be the same plane. It's now world YZ, because we're now drawing here. Our profile is going to be there, and our finger size is going to be here. Alright, so we now need to draw in the ZY planes, which is defined there, and it wants a point that the rectangle is starting from and a point that the rectangle is going to. Alright, you need to just have a look in your Rhino, move your mouse around, and look in the bottom corner here what your X and Y is doing. It helps you get your head around things sometimes. So I'm going to have a circle from 0 at 16.8. Alright, and now I need to put a profile either on the top or the bottom or the side, whichever blows your hair back. So I'm going to draw a profile and move it from that midpoint up there, and we're going to want to do a sweep with this, alright, around there. But we first need to work out this point and this point, because we want to draw a rectangle from here through to there. So we have three definitions to create a point. There's an X point, a Y point, and a Z number, which defines a point in space. So this point, my X is 0 because I'm working in YZ, so X will be 0 in both cases. So this is the starting point over here. X is 0, Y is the width divided by 2 multiplied by -1. Why are we doing that? Because this is negative and this is positive. This is going to underneath and this is going to over. This is minus, this is plus. You need to just bear in mind what that is, okay? So you're underneath over there, you're over here, you're underneath here, and you're over there. So I'm getting half the width that the user gave me because I want to come halfway over my finger rail. So I'm dividing the width by 2, multiplying it by -1 to give me a negative number, and then the height of it, the starting point of the height, is the finger size divided by 2. Alright, so looking back in Rhino, we've gone half the width backward and we've created a point over there, and we've gone half the height upwards. So we have 0, in other words it's flat on the ground plane, this far over and this far up is our start point. And then we've just done exactly the same thing for the ending point, except that for the ending point it's the width divided by 2 to give me half the width on the other side. I don't need to multiply by number 1 because I want to be on the positive side. And the height of it is again the finger size divided by 2, which gets you to the base rail band plus the thickness, which will take you up to, there's half your width, there's the positive, half the width, half the height, plus the thickness. So now you've defined 2 points. You've defined a point from here going through to there, which will draw a rectangle. Okay, so that's your everything you need to create the profile. The rectangle wanted which plane we're drawing on, which was the first corner, what was the second corner, plane, first corner, second corner. All right, now we want to create a BREP. I've got it as an array because when you create a BREP from a sweep, you may not have swept closed curves. You may have swept all kinds of things in there, which means that if you sweep 3 open curves, you can get 3 surfaces. So when this command runs, it expects an array in there. Whether we know that there's only going to be 1 or 2, Rhino doesn't know, and presumably you can break stuff. Okay, so you set an array, a BREP array called band, and we're going to create a BREP from a sweep. And the sweep wants to know what's exactly the same as Rhino. What is my curve rail, my curve shape? Is the sweep closed, and what is the tolerance of the sweep? All right. It wants curves. Curves. These are not curves. These are circles. These are rectangles. Okay. So I'm going to take the finger rail. I'm going to cast it to a NURBS curve. I'm going to take the profile. I'm going to cast it to a NURBS curve. Is it closed? Yes. What is the tolerance for it? I just used 001 because we work with 001. Now this may have returned 7, 10, 50 different things depending on what curve went in there. We know there's only one because we only set up one profile. We know the profile's closed because it was made as a rectangle. We only need to return the very first item in the array. So I'm going to return band, the first item in the array. And this return goes into there, and that BREP is set as data. Okay, and basically that's it. All you need to do now is you need to build your solution. If Grasshopper is running, you might have problems, so I'm going to just file and exit over there. Close that down. Alright, let's build again. Just pulling that up so I've got a bit more space. I like to every now and then just clean out my solution and then rebuild it. That's saying you're done. Okay. Now your problem is it's not put it anywhere in Rhino, and this is where a lot of guys get stuck. It's not in Rhino. Rhino doesn't know about it. Grasshopper doesn't know about it. All right. So go up to your main section, open the folder. All right. You see that you've got a whole lot of files in there. What we want is the binary file. Okay. So you go to the bin folder, clickety clack, and there's your tutorial file. Copy it. Okay. Hit percentage app data percentage. Press enter. Go to Grasshopper. Go to your libraries. You see my old one is what was in there. If I've updated it, just delete the old one, paste the new one, and it will now show up in Grasshopper. It's as simple as that. So let's open Rhino. Let's open the Grasshopper. And let's have a look in my extra folder. And you can tell that in my last build I changed the icon to a question mark. Up the top here, system drawing, system icons question. So that's why that changed in between now and then. And you can just now drag it out onto the screen, and if you get this, and it throws a lot of people off, if you get what looks like a funky thing that is not correct, just remember that you're on a very, very low polymesh setting in Grasshopper by default. Okay? We want to take that, switch it over to high quality, and bang, you have the correct view. Alright? You can now start attaching your sliders to these. Slider, number slider, let's pop it out there, let's change it to single point, let's change that to 20. I'm going to leave 0 in there to show you how the error works. Okay, I'm going to bring this over to some rational number. Now for the width and the height we need the same thing, so I can actually just copy and paste these. Control V and Control V, and pop that in the width, pop that in the thickness, and pop that on the inside. Alright, so the inside is my finger size in a diameter, and you can just pull that around and this will now happen. Alright, if you hit 0, the component goes red, and the little message we put in here, I'll show you the message again. Message said one of your sliders is too small. Alright, you cannot multiply, you cannot divide by 0. So if you hover your mouse over there, that's your error. Okay, so let's take that up to a normal-ish kind of finger size. Now these components will run super fast. Okay, super fast compared to having built this entire thing from Grasshopper previously, from all those bunch of little components. C# is easy to learn. Once you know the little trick about going to app data folder for Grasshopper, that becomes easy, and now you have a very fast, very efficient component, reusable for multiple things. Okay, you can edit this to have which plane do you want to work on, and you can make tubes from it. All right, so if you put an input over here going plane, you could change the direction that worked on, offset from the plane. Once you start adding a lot of stuff into here, you notice that it doesn't affect the speed as much as it does when it does inside of actual Grasshopper itself, because each component in Grasshopper has its own overhead, and it has to load, and it has to run runtime compile, and if you keep everything inside one program like this, it makes it very, very fast. Guys, I hope that helps. Cheers.